Hello everyone and welcome back to R&M LAB GH. Today, I want to share a small project born from a practical need in my workshop. Anyone who works with modern electronics knows how challenging it can be to test SMD microcomponents. Standard multimeter probes often slip, or they force you to use both hands, making it difficult to hold the board steady or manipulate other tools at the same time. To solve this problem, I decided to build a custom measuring tweezer. While similar tools are available on the market, I needed one immediately for an urgent repair, so I chose to build it myself using materials I already had on hand. It is an extremely simple tool, but once you try it, it becomes indispensable. It allows you to take precise measurements even in very tight spaces, and most importantly, it can be operated with just one hand. This leaves your other hand free to hold the circuit board or use the magnifying glass. For this project, I repurposed an old pair of straight-tip electronics tweezers that I no longer used. Although they weren't made of high-end material, they were perfect for this application. In addition to the tweezers, I used heat shrink tubing for insulation, 2 lengths of flexible wire, and 2 banana plug connectors to hook them up to the multimeter. Transforming these few items into a professional accessory is an excellent way to simplify daily tasks on the workbench. As you can see, this is a relatively straightforward build, but its simplicity is exactly what makes it so effective. The most critical phase of the construction is the electrical isolation between the two heads of the tweezers. Since we are dealing with precision measurements, any electrical contact between the two arms would make the tool completely useless. To solve this, I used a rigid plastic spacer to keep the two metal sides perfectly separated. I secured everything with high-strength super glue to ensure the structure remains stable even under pressure. To finish it off and provide a professional grip, I applied layers of heat shrink tubing. This not only reinforces the bond but also provides the necessary insulation for your fingers while working on live circuits. True versatility of this tool lies in the choice of banana plug connectors. This universal connection means you aren't limited to just your multimeter. You can easily plug these tweezers into a laboratory power supply, which is a game changer when you need to test SMD LEDs or inject voltage into specific points of a circuit without struggling with bulky alligator clips. I also want to highlight the importance of cable quality. By selecting a low-impedance flexible wire, I managed to eliminate unwanted passive resistance. As you can see from the test, when I short the tips together in continuity mode, the multimeter display hits a solid 0. Having zero tolerance in your leads is vital for accurate readings, ensuring that the value on the screen is the true resistance of the component and not the tool itself. It is a small addition to the lab, but the improvement in precision and workflow is massive. There is one more crucial detail I want to highlight, which is the importance of the color coding I've implemented. As you've noticed throughout the build, I used red heat shrink tubing for the positive arm and black for the negative. I also made sure the banana plug connectors matched this scheme perfectly. This isn't just for aesthetics, it's a vital safety and efficiency feature for your workbench. When you are focused on a complex repair, being able to identify the polarity at a glance is a massive advantage. Whether you are using the multimeter for quick continuity checks or connecting the tweezers to a lab power supply to test sensitive components, this clear visual distinction prevents accidental reverse polarity, which could easily destroy a micro-component. Furthermore, the heat shrink tubing serves another essential purpose. It provides complete grip insulation. By covering the metal arms where your fingers rest, you ensure that the natural resistance of your body doesn't interfere with the circuit. This is especially important when measuring high-resistance components, where even the slightest skin contact can lead to false readings on your display. I hope this project has been useful to you and has provided a practical idea to improve your own laboratory setup. Tools like these prove that you don't always need to spend a lot of money to get professional results. Sometimes, all you need is a bit of creativity and the right materials. Thank you so much for watching and for supporting R&M LAB GH. If you enjoyed this build, please leave a comment below and let me know how you would improve it. Don't forget to subscribe to the channel and hit the notification bell so you never miss my upcoming electronics projects. Thanks again for your time, and I will see you in the next video. Goodbye.